Welcome back, students. My name is Dolon Banerjee and I was discussing about the geotechnical engineering in the series of video lectures which is conducted by AKTU. Okay, so let us now we will be discussing about the laboratory compaction of soils. Okay, means how we get the compaction of different soils in the laboratory. Okay, so in lab what methods we go or use, okay, generally. So here we will be talking also about the compactive effort of different lab methods, means how much energy is being applied due to that laboratory method to the soil itself. Okay. So this is the compactive energy formula. What is compactive energy? Means how much energy is being applied to the soil per unit volume. Okay, per unit volume you can see divided by volume. So this is the energy which is being applied to soil of that specimen or the part or the soil which is being compacted in the lab. Okay, this is for the lab, we are talking about lab only for the time being, but this can be also used as generalized formula to calculate the energy supplied to the soil, okay, due to any kind of compaction it may be. So let us see. E is obviously the compactive energy. Now what is N? N is the number of blows per layer. You can see, suppose this is the specimen. Generally what we do, we either will be compacting the soil in 3 layers, okay, or sometimes we may also do it in 5 layers, like this. Okay, sometime in 5 layers or in 3 layers. Okay, so this will be N. Okay, oh sorry, it will be small n, and this is the number of blows. Number of blows is generally per layer we apply 25 number of blows. Okay, generally we apply 25 number of blows per layer. Here 25, again 25, again 25. Here also each we will be compacting with 25 number of blows. Weight of hammer, this is the how much the blow which is being given to this soil, what is the weight of this hammer. And height of fall, how much height of the fall is there. Okay, then the volume of mold, means if this is the mold, okay, suppose this is the volume of mold will be the volume of this, and this is the hammer itself, and from how much height the hammer is being punched or impacted onto this soil. Okay, this is the soil, this is the soil itself. So from how much height is the soil being compacted or the hammer is being discharged onto this, this is the small h height of fall. Okay, so now let us see one by one different. Now standard Proctor test, this is one of the tests which is generally used. Okay, so different specifications which we use in this test are, you can see, weight of the hammer, if you remember this was capital W, it is nearly 2.5 kg, 2.495 kg. Then height of fall which was small h, okay, how much it is, 304.8 mm or nearly 31 centimeter. Then volume of the mold, it was V, this is 944 cc. This test was actually conducted by a scientist, okay, to find out the compaction, okay, to find out the compaction. So he first of all carried out the standard, then again carried out the modified, okay, modified also, which we will be studying later on. So these two types of tests were conducted by the scientists. After that, the Indian IS code, okay, which we use, IS code, they made some changes or modification into these, and then we also use nearly the same compactive methods for the laboratory. Okay, the compaction is done in 3 layers with 25 number of blows, okay, as I have already told you. This is for 3 layers, you can remember. For standard it is 3 layer, and for modified it will be 5 layer. We will be seeing that. So now let us calculate the energy for standard Proctor compaction test. So E will be, what was the formula, N, okay, into N into what was there, this is a small h, okay, and what was this, 2.5, and this is the volume. Okay, so one by one we will, this is nearly, we can, this was actually 2.495, just now we have seen kg. So this is rounded off to 2.5, so this is W, okay, and this is used for the conversion only, 9.81, you can understand that. this is 10 to the power minus 6. This, don't get confused, this is the 10 to the power minus 6. Why is it this used? This is used to convert Cc, because this 944 was given in Cc, we need in kilojoule and meter. So, Cc to meter cube. For the conversion we have used it 10 to the power minus 6. Okay, you can understand that. So, when calculating this we find out 594.29 kilojoule per meter. Okay, per meter the kilojoule will be this much. So, this is the compactive energy which is being supplied to the soil per unit volume in the case of a standard Proctor compaction test. Okay. Further, let us move to the next test. Now, you can see this is the modified, as we are talking about modified Proctor test. Now, what will happen? The hammer has weight increased. Okay, it is weight is increased. Okay, this is the capital W. See, height of fall also has, it was nearly 31 mm or 31 centimeter. Now, it is nearly 45 centimeter. Volume is the same. You can see volume of the mold is again the same. Now, you can see this is 5 layer. There it was 3 layer. Now, it is 5 layer, and 25 blows is common for each layer. Remember this, not total, it is for each layer. So, again you will be finding out the compactive effort. So, 25, this is the number of blows, again this is the number of layers. Okay, this is the weight of the hammer, and this is the volume. Oh, sorry, not the volume. Okay, this is the volume. Okay, again 10 to the power minus 6 for conversion. Okay, don't get confused in this. This is also used for conversion only, same okay. So, all are now, what was this? This was the height of fall. Okay, height of fall. So, again we calculated out to get, now you can see how much the energy has increased. It was nearly 500, okay, 500 something kilojoule for standard. Okay, and now you can see for modified it is nearly 5 times. Okay, you can see this. So, accordingly the use we can see, if we are to find out the compaction for any place, suppose road, okay, which will be less compacted or less compaction energy will be applied there, then we can use this one. For buildings, if they are multi-story building and we have to find out the compaction in that part, then we can use this one, means standard or modified we can say. Okay, and standard will be for light compaction. Okay. Now, this is the just you can see here, this is the standard. See, this is 3 layers and this is compaction, and here 5 layers. Okay, this is a modified Proctor test and this is the standard Proctor. You can see this is just an overview. You can see this is 4.5, 2.5, 300 mm, 450 mm, 25 bow plus. Okay, number of layers 3, number of layers 5. This is just rounded off just to give you an overview of it. Okay. So, now if you remember, we had find out the curve, the compaction curve. This is W here and gamma D was here. So, this curve is actually obtained from this test only. You can see this is the Proctor curve or compaction curve. You can see this is the dry density and this is the moisture content. In lab, what we do, we carry out this test with different water content. Okay, and we find different this MDD or different gamma D, or we can say what is this? This is the dry density. Okay, the dry density. Then plot the graph to get maximum dry density. Okay. So, this method, Proctor's method, is actually used, or we can say compaction method is used for in the lab to find out this compaction curve. Okay. So, this is just the use. Now, compactive energy. Now, this is light compaction test. This is our IS code method. This is our IS code method. This is the method which is incorporated in our IS code. Okay. So, now we can see little modifications are being made, as I have already told you. This will be light. So, this will be corresponding to the standard Proctor test. Standard Proctor test. Okay. So, you can see weight of the hammer has been changed to 2.6, height of fall 3.1 or 31 centimeter. Now, volume 944 was there, if you remember 940. Now this is converted to 1000 cc. Compaction is 3 layer and 25 blows again. So now we will be calculating the energy which is being delivered by this. Okay, so you can see what will be the energy again, n, okay, small n. Okay, this is the weight of the hammer, and this is the volume, this is the height of the fall. So what we get, this is again the conversion. Okay, for conversion we will get 593. You can see this has increased because it was nearly 574. Okay, nearly 574 in that case, but due to some modifications such as this is modified, this modified, okay, this is modified as well. So what happened, slight increase is seen, okay, corresponding to the standard compaction test. Again for heavy, you can see the heavy compaction test, which is corresponding to modified Proctor test. Okay, so again you can see this is 4.9, 430, 1000 and 5 layer and 25 layer. So again this is obviously modified, these are also increased to some extent. Okay, so what will happen, again the compactive energy if we calculate, you can see it is again increased. Okay, this is greater than the modified Proctor test. Okay, so what we were discussing about, this is again, this is n, this is small n, number of layers. Okay, and this is the volume obviously, and this will be the height of fall, and what will be this 4.9, this is the weight of the hammer. So we again get the energy which is being delivered to the soil per unit volume by the heavy compaction test. Now just let us go to a numerical based on these tests only. Compare the compactive energy used in IS heavy compaction test with that of IS light compaction test. Means both IS methods are to be made comparison about their compactive effort, which we just calculated as well. So compactive effort for heavy will be, just now we calculated. Okay, this is in kgf, for the unit is different, but you can compare in the same unit as we have calculated before. Okay, which was 27 something, we can also compare in that. Okay, the result will be same. Here their units are different, so the values are different as well. Okay, again we calculate for the light compaction. Okay, so what we get, this is the, you can remember this because it also used this will be also used different times in the competitive exams also. This is asked directly, what is the ratio of heavy to light compaction test okay, heavy to light compaction test. This is generally asked as well. So you have to remember this is 4.56 nearly. Okay, so this was it for the time. You can go through the questions and answer them. Okay, so next time we will be discussing some further new topics in the geotechnical engineering part. Okay, so stay connected. Thank you.